I'm Dr. Sarika Panwar, Assistant Professor in Department of ENTC AISSMS IOIT. Today, I am discussing one IoT Internet of Things experiment with you. The experiment name is Uploading Soil Moisture Sensor Data on ThingsPick using Node MCU. In this experiment, we will interface the resistive soil moisture sensor with Node MCU ESP8266 and we will monitor the soil moisture data on ThingsPick Server. We are going to interface a resistive soil moisture sensor FC28 with Node MCU ESP8266 board. This sensor measures the volumetric content of water inside the soil and gives us the moisture level as output. The sensor is equipped with both analog and digital output, so it can be used in both analog and digital modes. Here, today, we will use the sensor in analog mode and measure the soil moisture in percentage. The components required for this experiment are Node MCU, Arduino IDE, breadboard, connecting wires, and soil moisture sensor. This is ESP8266 Node MCU. On this board, we can observe that there is ESP I2E chip available and 3.3 volt voltage regulator for giving the 3.3 volt power supply. Flash button and reset button are also there, uh, which can used for uploading the code. There is USB to TTL converter also, which will make our board compatible for TTL logic. Onboard LED pin LED is available, which is connected to D0 pin. And since this is a Wi-Fi module, 2.4 gigahertz antenna is available on board. This is a pin configuration of Node MCU, in which we can observe here that there is one ADC input pin, and we will connect our A0 output, analog output of the soil moisture sensor to the ADC pin. Now, in this diagram, we can observe that various general purpose input output pins are available and 3.3 volt power supply pins are also available. For every GPIO pin, IO indexing number is given. So whenever we refer that particular GPIO pin, we have to refer it by using its IO index number. Like when we use pin GPIO 13, we have to refer that GPIO 13 pin by using D7 pin. This is the interfacing diagram of the experiment, in which we can observe that soil moisture sensor is interfaced with Node MCU and the data of the sensor is sent on the ThingsPick cloud. The soil moisture sensor, this FC28 soil moisture sensor, consists of two probes. These are the two probes that are used to measure the volumetric content of water. The sensor works between the input voltage range of 3.3 volt to 5 volt. So we can give, you can observe in this diagram that there are 4 pins: PCC, ground, D0 and A0 pin. These 4 pins can be used for the interfacing. Now, since this is passive sensor, we have to provide the power supply and it can work on 3.3 volt to 5 volt power supply. In this case, we are giving 3.3 volt power supply, which is available on board of Node MCU. The output voltage given by this is between output voltage we will get on the A0 pin, and that is in between 0 to 4.2 volt. The output signal appears both in analog and digital form, A0 and D0 respectively. This module also contains this potentiometer. This is the potentiometer that will set the threshold value, and then this threshold value will be compared by LM393 comparator. The output LED will light up. Here output LED is there. It will light up and down, up and down according to this threshold value. The soil moisture sensor consists of two probes. These are the two probes that are used to measure the volumetric content of water. Two probes allow the current to pass through the soil and get it to measure the moisture value. When there is more water, the soil will conduct more electricity, which means that there will be less resistance. Therefore, the moisture level will be higher. Dry soil conducts electricity poorly. So, when there is less water, then the soil will conduct less electricity, which means that there will be more resistance. Therefore, the moisture level will be lower. The connections are very simple. We are using the soil moisture sensor in analog mode. So we have connected the analog output. See in this diagram. Analog output, this A0 output to the A0 pin, that is ADC0 pin of the Node MCU. Now uh, we have to monitor the sensor data on this ThingsPick cloud. So in order to monitor the sensor data on ThingsPick server, we first need to set up the ThingsPick. And uh, for setting up the ThingsPick server, we have to visit this thingspick.com, and we need to create an account or simply sign in if you created the account earlier. Okay, so that we will discuss now how to create the accounting on ThingsPick server. Our Arduino IDE for soil moisture sensor interfacing with Node MCU and ThingsPick. Now in this code we can observe that there is a library included for ESP826655 module. Now this string API, this string API, this we have got from the API key we have got from the ThingsPick, that I will show you later how to get the API key from the ThingsPick. This is the user ID and password for the Wi-Fi connection which we are using to connect our ThingsPick Node MCU server with the Wi-Fi. Now here the sensor pin A0 pin of the Node MCU ADC, it is referred as a sensor pin in our code, and we are sending the data on serial monitor window. So we have to select this serial communication baud rate, that is of 11.5 to 00. So after giving a delay of 10, now we will just print the message on the serial monitor window that connecting to the Wi-Fi. Then if Wi-Fi is, it will also show the status whether Wi-Fi is connected or not. So for that we have written this while statement. So it will check the Wi-Fi status whether it is connected or not, and if it is connected it will give you the message Wi-Fi connected. So all these things we did in the setup void setup loop function. Now let's come to the void loop function. In void loop function, we are just reading the sensor pin ADC0 pin from the analog read by using analog read function, and then that is divided by 1023 because we have to convert that into the digital form, and then in percentage also. So 100 minus that converted value will be stored in moisture percentage variable. And now we have to display this moisture percentage on serial monitor window, as well as we have to send it on the ThingsPick. So serial.print function will write this message on the serial monitor window, soil moisture in percentage, and then soil moisture percentage will be printed, which is stored in this variable. Then we have to send this soil moisture percentage to ThingsPick. So we are using this server address client.server 80, because now our Node MCU has become the server who has got port address of 80. Okay, and that from that we will send it to the things pick cloud, and it will use this API key. API key variable, you can observe here that in API key variable, actual API key which we have received from the ThingsPick server has been stored. Mm, Now here we can the this whole code will send this Node MCU server data to the ThingsPick client data. Okay, so that's why we are using this client dot print statement, and it will also send the message serial.println data sent to ThingsPick on the serial monitor window. Okay, so this is a very simple code, and once the data is sent, now client dot stop function is used, and then after the delay of every 2 seconds, the data will be updated on the serial monitor window, and the data on ThingsPick cloud server will be updated after every 15 seconds. Okay, so now we will upload the code first on our. Now once the code is uploaded, you can observe that code is uploaded here. It will, once the code is uploaded, it will show the message done uploading. Now you can observe on the serial monitor window. Actually it has shown some error, so we will check the. Okay, it has done uploading. Okay, once the uploading is done, now we will observe the output on serial monitor window. You can see here on serial monitor window the soil moisture in percentage is uploaded, and if I put this probe of soil moisture sensor into the soil, then it is changing the soil moisture percentage in up to 50 to 45, because soil is moderately dry. Now we have to observe the ThingsPick server. See, now for ThingsPick, what we have to do, first we have to go to thingspick.com. Okay, so if you go to thingspick.com, and uh, if you have already registered, then you will have to sign in with your login ID and password. But if it is not registered, then you will have to register it first, and then you will get your password, and with that password you can log in with on the ThingsPick cloud server. Okay, now here you can observe that there is a channel option. So on if you press on this my channel option, then it will show you the new channel, create new channel option also. But in my case, now I have already created my channel. But if you, I will show you the step of how to create a new channel. So if you want to create a new channel, just press on this new channel option. Actually net is slow, so So now here you can observe this is the new channel option. Here you can give the name to your channel. So I will just give you the name soil moisture sensor data display. You can give some description like soil moisture in percentage. Now see on the field 1 actually you have to um, give some label. So we will give this label soil moisture in percentage, which it will be displayed on the y-axis. So once it is done, uh, we have to save our channel. Once the channel is saved, you will get the API key. Okay, you will get a channel ID. The channel ID is 1132597, and you will also get the API key. So see, this is the you will get two API keys, write API key and read API key. So we will use write API key because we are going to write the data into the cloud. That's why we will use this. You have to copy this write API key and put it in your code. Now in this code you can observe string API key variable is declared, and you have to this a variable will save the API key. So here you have to copy that API key. Okay, and now once that API key is copied here, now I will not just copy it, we will use the existing channel which I have already created. Once the channel is created, now I have already created the channel sensor, soil sensor data modified. Now you can observe here that it is showing the soil moisture. So I have started this activity at 1:34 p.m. and now at every time instance it is updating the data. See at 1:35 1:52 p.m. It was soil moisture was in 98%. Okay, and now it is as I am changing the soil moisture probe from water to soil, from soil to in just air. So it is updating the soil moisture. So now at this instant of time, it's 3:41 now. Okay, so at 3:41 soil moisture percentage is 41%. Okay, so this is how it will display the soil moisture percentage. So you can open this ThingsPick on the remote ID also, on remote laptop or your mobile phone also. Okay, so that is the advantage of this interfacing, that remotely you can access the sensor data by using this experiment. Okay, thank you student. This is the Node MCU. This Node MCU is connected with the laptop by using this micro USB cable. This white cable is micro USB cable which is connected to the laptop. Now this is ADC 0 pin. This pin is the ADC 0 pin of this Node MCU, and these two are the supply pin from where we will get the 3.3 volt supply to this soil moisture sensor. See, this is the soil moisture sensor probes. These are the two probes of soil moisture sensor which are connected to this sensor part, which has got the 4 pins. Now this first pin is the VCC, then second one is ground, this is D0, and last one it is the A0 pin. Now since we are using the analog output of this ADC, we will first connect this VCC, this red is connected, this red wire is connected to the 3.3 volt of this Node MCU. You can observe here, this is the 3.3 volt Node MCU connector, which is connected to VCC of the sensor. This is connected to VCC of the sensor. Now ground of the Node MCU is connected, because this is passive sensor, we need to give the supply to the Node MCU. You can observe, as soon as we have given the power supply, the power LED of the sensor is turned on. Okay, now this black wire, which is already connected to the ADC 0 pin of the Node MCU, now we will connect it to the A0 output, that is analog output of the soil moisture sensor. Now we will upload the code which we have already written in the Arduino IDE. By pressing this verify button, we are compiling the code. Now it is showing the message done compiling. Here it is showing the message done compiling. Once the compile is done, now we will upload, we will press the upload button, and when we press the upload button, simultaneously we have to press this flash and reset pin, so that uploading will be successful. Now you can observe that the code is getting uploaded on the board. It is showing the message done uploading. Once the code is uploaded on board, now we can observe, we will open the serial monitor window. See, this serial monitor window is open. It is showing the message data sent to ThingsPick. It is waiting, soil moisture in percentage is 0. Now we can observe that this is not inserted in soil, that's why it is showing the 0% soil moisture. You can observe that the soil moisture percentage which it is showing is 0. Okay, now if I insert this probe into the soil, it will increase the soil moisture percent up to see, now the soil is moderately dry, so it is showing the 52% of moisture in the soil. Okay, now we have to see how it will send the data on the ThingsPick. Okay, so what I will do now, I will open the ThingsPick.com. See, here we can observe that in my internet browser, ThingsPick.com is opened, and in the ThingsPick.com now I have already created the channel. So the channel name is the soil moisture sensor modified, that is the channel name, and it has given me the API key. That API key I have already stored in the code, and now you can observe that here it is displaying on the ThingsPick cloud server. It is displaying the soil moisture. Okay, and it will update the soil moisture percentage after every 15 seconds. Okay, now see how much is it showing. It is showing the 50% moisture. Okay, so if I put my cursor on this particular level, then it is showing 52% moisture, which is same as that of the moisture percentage which is displayed on the serial. Now it is updated to 33%, so definitely it will also update it on the ThingsPick cloud. Okay, so see here, now it has been decreased to 33%. Now if I insert this probe into the water directly, then definitely the soil moisture percentage will be high. Okay, so now you can observe that soil moisture in serial monitor window, soil moisture percentage has been increased up to 61%, 75%, and now we will observe it on the cloud server. Okay, so now on cloud server it will update after 15 seconds, so we can observe it after 15 seconds that the moisture level has been increased, that we can observe after 15 seconds. We can observe here that now the soil moisture percentage, after inserting the soil moisture probe into water, the soil moisture percentage has been increased up to 66%.